This video is over topic 9.1, solving systems of equations by graphing. So the first part is a system is two or more equations. So if you have anything more than one equation, it is classified as a system. You can have two, you can have three, you could have 10 if we wanted to get crazy, but anything over one is called a system. The solution to a system is where the lines intersect or where an x and a y value make both equations true. So this first problem, we have a system that they want us to solve by graphing. In order to graph, we have to solve for y. The first equation's already been solved for us and graphed for us. So they started up at 2, they went down 2, right 1, down 2, right 1, down 2, right 1. From the graph, I can see that when x is negative 3, y is 8. When x is negative 1, y is 4. And when x is 2, y is negative 2. The second equation has also been graphed solved for us, but we have to graph. To fill in the table using the green line, when x is negative 3, y is negative 7. When x is negative 1, y is negative 5. When x is 2, y is negative 2. Now again, as it showed up at the beginning, our solution is where the lines intersect or where the x and y of both tables are the same. So no matter how we look at it, whether we look on the graph or in the table, we are looking for where the lines cross. They cross at 2, negative 2, or where the table points are the same. 2, negative 2, 2, negative 2, they are both the same. Problem 2, these have both already been solved for y, and they are just asking us to graph and fill in the table. When x is negative 4 on the blue line, y1, y is 7. When x is 1, y is negative 3. And when x is 4, y is negative 9. The second equation will start at 3 and go down 1, right 1, down 1, right 1, down 1, right 1. Unfortunately, as I'm moving down and to the right, I'm getting further away from my line, and remember, I'm needing to find the point where they cross. So I'm also going to go up and left, and I'm going to keep plotting points until my points overlap. You will be much more accurate if you look for where your points overlap rather than where your lines cross, because some of us are not good at drawing lines. For the green equation, when x is negative 4, y is 7. When x is 1, y is 2. When x is 4, y is negative 1. So again, where my points cross or in the table, my points are exactly the same. Negative 4 and 7. The green line has already been solved for us, graphed for us, and the table has been filled in for us. We have to do all of that for y1, which is the blue line. So I move the x to the other side. So negative y equals negative 2x plus 4. Divide everything by negative 1, and y equals 2x minus 4. So I'm going to start down at negative 4, up to right 1, up to right 1, up to right 1. And again, I'm looking for that point where they cross. So when x is negative 3, y is negative 10. When x is 0, y is negative 4. And when x is 3, y is 2 on the blue line. So looking for where they cross, this table is a little different because it's two tables in one. So what I'm looking for here is the same y values when the x is not changing, the same y values. So this would be the solution, 3, 2. On the back, the blue line has already been solved and graphed for us. We need to graph the green. We're going to start up at 1. And my slope is up 1, right 3, up 1, right 3, up 1, right 3. I can look and see that I'm not crossing, so I'm going to keep going down 1, left 3, down 1, left 3, down 1, left 3. Now if you notice, these lines are parallel. Slopes are the same, y-intercepts are different. So when you have parallel lines, your solution is none, or no solution, because if you're looking for the one point where the lines cross and the lines never cross, then you can't have a solution. So anytime you have parallel lines, your solution is no solution, not a 0, but a no solution. So a 0 with a slash through it, or the words no solution. For problem 5, the blue line has already been solved and graphed for us. We solved for y and started up at 4, went down, or up 1, right 2. So I'm going to solve this one and graph it as well. So negative 6y equals negative 3x minus 24. Divide everything by negative 6. And y equals 1/2 x plus 4. Now if you notice, my lines are exactly the same. So when I graph, the green line is going to cross everywhere on the blue line. So if your lines are exactly the same, your solution is all reals. You could also see it as infinitely many. Down at the bottom, to wrap up, they ask us to tell whether the ordered pair is a solution to the system of equations. So again, just like we did with inequalities, if it works in both, if it's true in both, then it's a solution. So on the first one, these are both true, so it is a solution. On the second equation, we have one that's true. We need to test that the other one is true. And remember, I plug in x, whatever they gave me as my point. Instead of x, I'm writing negative 3. Instead of y, I'm writing negative 10. Negative 10 is positive 10. And then 9 minus 19 is a negative 10. Well, negative 10 and positive 10 are not the same. So this one is false, and it is not a solution. So remember, when you are point testing, label your point. Instead of x, write whatever x is. Instead of y, write whatever y was, and simplify. So in conclusion, systems have one solution if the lines cross. They have no solution if the lines are parallel. And they have infinitely many if the lines are the same. So using that information, you should be able to complete 5-1 or 9-1.